Time for some more kitchen table astronomy with Hampshire College astronomer Dr. Salman Hameed, Mr. Universe, at your kitchen table here in Amherst. But first off, you were like the belle of the ball at the NEPM open house that we had the other day. Everybody was psyched to meet you, including NEPM reporter Nancy Cohen, who spent a great deal of time talking with you.
Hey, I was so excited to be sort of like, invited over there. And no, that was a great event and a really fantastic building. And I also took a tour and saw sort of like, where the sort of like the magic happens.
Yes.
And so that was great and wonderful jazz performance.
Yeah, with our new jazz host Friday nights, Avery Sharp. Come on, he's
that
great.
was really cool. So it was really fantastic.
You can come to things like that in the future, listener, if you support NEPM. It's made possible from listeners like you. I love saying that. Anyway, we're going to talk about Earth's baby, the moon. The moon is the Earth's baby because we birthed the moon, right?
Well, I don't know who we is in this.
We meaning Earth.
Well, okay, all right. Yes, that is kind of true. So one of the big questions, or I would say, I actually find this interesting because always you can think about, hey, if you see something, you go like, where did it come from? Right, and that actually connects that. And of course, we see the moon all the time, or at least when it's in the sky, visible to us. And you would ask the question, hey, how did it form?
Yeah. Where do babies come from?
And it is a surprisingly difficult answer for that, or difficult question to answer, unlike the baby question. The baby question is a little bit easier.
Storks.
Right, exactly. So here, up until the Apollo missions, there were a couple of theories about the formation of the moon. And the moon, I should mention, Mercury doesn't have a moon, Venus doesn't have a moon, and Mars has small moons. Our moon, compared to the Earth, is actually quite big. So the question was, how did it get formed? Because it doesn't fit in. It's almost an exception to that. And there were ideas that maybe it got created with the Earth, but there were problems with that particular model. There were thought that maybe it was captured, like for example, Mars's moons are thought to have been captured.
Meaning stuff is just floating around in space and it gets caught in the orbit because of gravity, because of how big the planet is. It gets wrapped up in its orbit.
Right, and that didn't make sense. And Jupiter's moons were formed sort of like together with it, just like a solar system to a certain degree. But that model didn't work because how one big body got formed. And so we actually didn't know. But with Apollo astronauts going to the moon and bringing back a lot of rocks from there, when they analyzed it, it looked like that the moon was made up of similar material as the crust of the Earth. And that suggested, well, perhaps there is a connection to that. And now what most astronomers think, that our moon was formed when a large Mars-sized body, and astronomers then given it a name, Thea, which is I think the mother of the moon in the mythology, when it crashed into the Earth very early on, 4.5 billion years ago, and it slammed and it was a glancing angle, and the material went up in sort of like in orbit, debris, and that debris coalesced because of gravity and formed the moon. And so that's it's also called, I think, the big whack theory because it's kind of cool.
Yeah, got whacked by a Mars-sized object.
Exactly.
Out of the Earth's body, a baby is born called the moon.
I'll call it also the Sopranos theory, the big whack theory. But anyway, so that is the idea behind that early on in the solar system, a large body collided. And somebody might say, well, what if some body like this come in today and hit us? Well, you don't have those free-floating large bodies today. It was early in the solar system where you have proto-Earth, and you have these protoplanets basically roaming around, and sometimes, they could actually crash into each other. That's how our Earth grew to a certain degree as well, by accumulating material. By accumulation, it means sort of like things crashing into it, but occasionally you would have a big body crash into that too. So that's the existing idea, and I mean, and it's phenomenal because the things happen on a very short time frame. So when we think about, how long did it take after that for the moon to form into the shape that it is at? And up until recently, people actually thought that it would take perhaps a few years to maybe 100 years, which still is very short. But then, I think 2 years ago, or last year, in fact, new supercomputer simulations have come out. They actually think that it all happened within a few hours.
What?
And if you just think, that's just insane, right? And so people are still trying to figure out, and this happened a long time ago, obviously. There were no TV cameras there.
No.
And there were no videos.
Yeah.
And so you are trying to piece together how exactly it happened. And not to mention that earlier on, the moon was much closer to the Earth. And slowly it has been going farther and farther away. And so that also has been taking place. But the reason why I'm talking to you, Monte, here is because the question was, hey, what happened to Thea? Did it just go away? Is there any evidence for Thea?
Meaning this Mars-sized object that hit the Earth, grazed it, and shot the moon out of us, and then maybe even in hours formed the moon as we know it.
Exactly. And now it looks like maybe there is an evidence that there is Thea under the Earth, inside the Earth.
Whoa!
And so this is actually pretty cool. So here is there is a Caltech what's called geodynamic researcher, Kian Yuan, who has who's the lead author on a paper that just got published in the journal Nature, and we knew that inside the Earth, so people can actually figure out the structure of the Earth through seismic waves when there are earthquakes, and the way these waves basically go from one side, these shock waves from one side of the planet to the other, how long it takes to reach different places. You can actually tell a lot of information. You can get a lot of information about what is inside the Earth, what is the structure of the Earth, because you cannot dig through it. And so back, I think in the 80s, people knew that there were these two slightly higher density objects that were there, and they gave the name. One was under West Africa, and one was under the Pacific Ocean. These were just like pieces that were higher density, and they were like sticking out from our mantle, like in the place between the mantle and the core. They were just sticking out. And one, they gave the name Tuzo, after a Canadian geophysicist who was actually explaining sort of like plate tectonics. And the one under the Pacific Ocean, they gave the name Jason, after Jason Morgan, another scientist.
Not the Argonauts.
Not the Argonauts.
Or Jason Voorhees.
So you have these two pieces, and they are located close to about, I think about like 1,800 miles under the surface. And they're sticking out a few hundred miles above the sort of like, from the place where the core and the mantle meets. So the question is, what is that? And now this paper has come out that says that actually that may be the remnant of Thea. And that's actually interesting. And again, you cannot just imagine sort of like, how did it come in? Of course, there was a lot of mixing that happened. So again, through computer modeling, they actually showed that Mars-sized object Thea, it had a slightly higher density. And this was again one of those things that was a puzzle, because on the moon, in some places, or some material had a higher density compared to the Earth's crust. And so people were wondering, what is that? And so they expected Thea to have a higher density, and that material, a lot of that material, fell into the Earth. And only 10% of the one that made the moon. But rest of it actually went to the Earth, it mixed in, but over the period of time, because it has slightly different density, it gelled together into these two giant blobs, which are the size of a continent. And each of them is comparable in volume to the moon. And they exist inside the Earth.
So this comparable volume thing that's a different density smacks into the Earth, shoots a similarly volumed density out as the moon from the Earth, and then buries itself under the mantle, between the mantle and the core.
As far as I understand, it's actually mostly mixes in to the Earth. A lot of the material in the crust area just mixes together and becomes part of Earth's minerals. But some of the material sinks in, and over the period of time, it sort of like, because there are plumes that bring it up and down, it solidifies into these two large bodies.
It sounds like the Jurassic armored mud balls that we were learning about a couple weeks ago on the show, where these like awesome things that rolled down riverbeds in the Jurassic period and armored themselves with riverbed stones are embedded in the rock structure, and we only have these kind of things here in Massachusetts, as far as we know. Thanks, Professor Richard Little, for bringing that up. This is like on a global scale. These are our Jurassic armored mud balls that created the moon. It's just fun to say Jurassic. Fun to say Jurassic armored mud balls.
I agree. So yeah, Jurassic armored mud balls theory. I don't know how similar it is, but I mean, hey, why not? I mean, you know,
Right.
But this is just really fascinating that you can actually start to figure out what is inside the Earth. And again, we cannot go and dig 1,800 miles under the surface to see what is really out there. But to me, what's interesting is one, that we can actually figure out through these earthquakes, through these seismic waves, the structure of material that is in there. And you find that there is a little bit of oddities in there, Tuzo and Jason. And then you figure out, wait a minute, perhaps we can figure out how Tuzo and Jason are related to the formation of the moon. And all of that, it just requires amazing imagination and then amazing mathematics to have those simulations run. And you can tell what happened 4.5 billion years ago. And so next time if somebody asks, hey, I see the moon, hey, where did it come from? And the answer is, storks. No, I mean, no, Thea. Thea. You mean a large body crashed, and we also know that that large body now lives inside the Earth.